For chapter 1, lecture 3 of 3, we are going to continue with the next subtopic, which is 1.3, indices, surds, and logarithms. So the learning outcome for today is to, at the end of the lesson, students should be able to explain the meaning of a surd and its conjugate and perform algebraic operation on surds. Okay, what exactly is surds? So you don't remember during your high school because we never learned it, but actually surd is an irrational numbers written in the root form square root to express its exact value. So literally surds is the square root of a value where the value cannot be found in a perfect form. For example, square root of 2, square root of 5 are surds. So if you try to calculate by using your calculator, you will get an irrational number. How about surd 9? Surd 9 is not a surd. Why? Surd 9 can be calculated into surd 9 is equal to 3. Yes, is equivalent to 3. Some surds can be simplified to a mixed surds. For example, surd 12 is actually 2 surd 3. Why? How we get this 2 surd 3? So we are going to move for the next slide, which is to use all the rules regarding surds. Okay, rules of surd. The same as rule of indices, we use this rule to simplify the surds. For the first one is square root of a multiplied with b. It can be written as square root of a multiplied with square root b, where a and b should be more than or equal to 0. Okay, so this value can be written in a multiplication between two values. Okay, for the second one is square root of a over b is equivalent to square root of a divided with square root of b. So the division between two values can be written separately for the square root or for the surd. So a and b should be more than or equal to 0, but b cannot be 0. It should be more than 0 only. For c, so square root of b plus and minus of c square root of b. So we have the same square root here, square root of b. So it can be written as a plus or minus c multiplied with surd b. So this one is actually just like you do for the equation. For example, 2x plus 3x. So we have the same representation here. So we just add up the coefficient. So what we have is 5x. This is the same as this example. Okay, but what we have here is square root but not x. Okay, so the results here from these three rules is when we have a square root of a multiplied with square root of a, we will get a. Why? It's a square root of a square. So we can cancel out the square root and the power 2. Why? Because square root is the power of 1 over 2. And then for this one, a square root of a plus square root of a is actually have one coefficient of each of the square root. So this one is like x. So it's like 1x plus 1x. We have 2x. So this one, surd a plus surd a is equal to 2 surd a. Okay, so what is the next rule? So the next rule is actually the expansion of addition between two surds. So surd a plus surd b all to the power of 2 can be expanded. So what we should do is to expand each of the term, multiply each of the terms. Surd a multiplied with surd a, and then surd b multiplied by surd a, and then surd a multiplied by surd b, and surd b multiplied by surd a. So step by step, what we will get is surd a multiplied by surd a is equal to a, right? And then surd B multiplied by surd A is surd A surd B. And then surd A multiplied by surd B is surd A surd B. And then surd B multiplied by surd B, the same as surd A multiplied by surd A, which is B. So we have 2 of surd A surd B, which is we can apply the first rule. So it's actually surd of AB. So we have 2 surd of AB. Okay? So remarks that surd A plus B, surd of A plus B is not equivalent to surd A plus surd B. Okay, so let's do some algebraic operation on two surds. So we have to apply all the rules we've learned before. So addition and subtraction between two surds. So we can allow for the like or the same surds, just like when we see the rules before. So add or subtract the number outside the surd. So the coefficient of the surds. So for example, 4 surd 7 minus 2 surd 7. So we have the same surd here. So we can do the addition or subtraction here. So what we need to do is just add or subtract the number outside the surd. So what is the number outside the surd? 4 and minus 2. So 4 minus 2 is equal to 2. So 2 surd 2. 5 surd 2 plus 3 surd 3. So do we have the same or like surds? So surd 3 here, surd 2 here. This is not the same surd, so we cannot do any addition or subtraction. Okay. Multiplication. How about multiplication? So multiply the number outside the surd together and the number inside the surd together. So we multiply in each category. So for example, 5 surd 2 multiply with 3 surd 3. So we multiply the outside together. Okay? So multiply the outside together. So 5 multiplied by 3, we get 15. And then multiply the inside surd together. We still keep the surd. So we have 2 multiplied by 3, 6. So it is surd 6. Okay? Okay, let's do some example on this subtopic. So the example one, we want to simplify all of this. So for the first question, square root of 45. So what we should do is to let this value into multiplication between two values. So what we want to do, the first step is to recognize whether this value can be separated by two values, and one of the value is a perfect square. So what it means by perfect square? So perfect square, for example, is square root of 4. Why is it square root of 4 is perfect square? Because it can be written in a natural number. And then square root of 9 is a perfect square because it's equivalent to 3. Square root of 25 is equal to 5. Square root of 64 is equal to 8. And then square root of 49 is equal to 7. So all of this value, 49, 4, 9, 25, 64 is a perfect square value. So for this one, square root of 45. So what is the perfect value can we choose? Yes, it is 9 multiplied by 5. And then by applying the first rule of surd, it will be equivalent to square root of 9 multiplied with square root of 5. So put it separately. So what we can have later is square root of 9 is a perfect square, which is equivalent to 3. So the answer will be 3 surd 5. Okay? Question. So question B is square root of 24. So as I said earlier, we want to change this value into two multiplication between two numbers, and one of it must be a perfect square. So what perfect square will we have? So from multiplication table, so we know that this is equivalent to what? It can be 3 multiplied by 8, 12 multiplied by 2, and then 6 multiplied by 4. Which one of these is a perfect square? So we have 6 multiplied by 4, where 4 is a perfect square. So we choose 4 multiplied by 6 or 6 multiplied by 4. So applying the first rule of surds, we have surd 4 multiplied with surd 6, which is equal to 2 surd 6. Okay. See. So surd 6 surd 7 plus 2 surd 7. So this is addition between two surds. So what is the criteria that we can do for addition and subtraction? We have to make sure that the surd have the same value. So this one is surd 7, this one also surd 7, so we can do the addition. So what we should do, we just add up the coefficient. So what we will have? We will have 6 plus 2 of surd 7, which is equal to 8 surd 7. Good. And then for question D, 5 surd 3 minus surd 27. So, as I said earlier, we have to make sure the surd have the same value. But here, what we have is surd 3 and surd 27. It's not the same, but it almost the same. Why? This 27 is a multiplication between 9 and 3. Okay, so what we will have later is 5 surd 3 minus square root of 9 multiplied by 3. And then we can separate by using the first rule of surds, which is surd 9 multiplied by surd 3. So what is surd 9? Surd 9 is a perfect square, which is equal to 3. So this part will be 3 surd 3. So we can apply the rule of surd for addition and subtraction, where we just have to do the operation with the coefficient here. So what we have as the answer? Yes, 2 surd 3. Good job. Okay, for question C. So we have the question of 8 surd 2 multiplied with 5 surd 6 plus surd 2. So what we can do, we have to apply the expansion multiplication between two surds. So applying the multiplication between two surds, 8 surd 2 multiplied with 5 surd 6, where we multiply the outside and then the inside together. So what we have, 8 multiplied by 5 is 40, 2 multiplied by 6 is 12. And then for this part also, 8 multiplied by 1 is 8, and then 2 multiplied by 2 is 4. So we have this as the expansion. So after that, what we should do? So we have surd 4, directly it's a perfect square, it's equal to 2. How about the surd 12? So surd 12 can be written in a more simple way. Okay, because 12 is a multiplication between two values. So we can separate the 12 into 4 multiplied by 3. So the surd 4 later will be 2. And then this 8 multiplied by 2, we have to multiply each numbers lah. So 40, we have 40 multiplied by surd 4, which is 2 surd 3 plus 16. So simplify everything. This 40 multiplied by 2, we will have 80 surd 3 plus 16. That is the answer. So for question F, so we have these two expression here. So what we have to do, as usual, we have to expand. 2 surd 3 multiplied by 6 surd 3. So surd 3 multiplied by surd 3 will be 3 directly. 2 multiplied by 6 is 12. And then the next one is, 2 multiplied by 2 surd 3 multiplied with 2 surd 2. So 2 multiplied by 2 is 4. Surd 3 multiplied by surd 2 is surd 6. And then 4 surd 2 multiplied by 6 surd 3. So 4 multiplied by 6 is 24. Surd 2 multiplied by surd 3 is surd 6. And then the last one is 4 surd 2 multiplied by 2 surd 2. So 4 multiplied by 2 is 8. Surd 2 multiplied by surd 2 is 2. So simplify everything. This one is 36, 4 surd 6 and 24 surd 6. We can apply the addition rule. So what we get is 28 surt 6, and the last one 8 multiplied by 2 is 16. So add up 36 to 16, we will have 52 plus 28 surt 6. Okay, that's it for F. Let's move on to the next. So, conjugate of surds. So what is conjugate of surd? Earlier we know we have a conjugate for complex number where we have to change the sign of the imaginary part. How about surd? So surd is the sum and difference of two surds are conjugate surds to each other. What it means by that? Means that if we have surd 7 plus surd 2, the conjugate is surd 7 minus surd 2. So what we have to do is to change the second sign. And then, for example, again, negative 5 surd plus 2 surd 3 is conjugate of negative 5 minus 2 surd 3. So, plus and minus here. And then, so, change the middle sign. What we have to do, we just change the middle sign. Okay, multiplication of conjugate of surd give you a rational number. So what will we do after we multiply between its with the value with the surd and its conjugate? We will have a rational number where there is no surd left. So let's say this is the example, surd A plus surd B multiplied with its conjugate, which is surd A minus surd B. So we expand everything. Surd A is equal to A. Surd B multiplied by surd A multiplied by negative surd B, we have negative surd AB. Surd B multiplied by surd A is positive of surd AB, and then surd B multiplied with negative surd B is minus B. So this one can be cancelled out. So what we have is left with A minus B. So we don't have surd in the result. Rationalizing a denominator. So let's say we have a fraction. We always simplify the form with no surd in the denominator. So how do we do it? So multiply, we have to multiply both numerator and denominator by the surd kalau if we have one term only. And then the conjugate of the denominator if we have two terms. So rationalize the denominator of the following fraction. So we have two questions. The first one, 3 over surd 2. And the second one is 2 surd 3 over 5 minus surd 3. So the solution for question A. So what we have here, the denominator have one term only. So if one term, what we should do, we just have to multiply with the surd. So 3 over surd 2, we should multiply with the surd 2 on the numerator and the denominator. So multiply everything. 3 surd 2, we just have to multiply, and then surd 2 multiplied by surd 2, what we have is 2. So we don't have any surd in the denominator anymore. So because we have two terms in the denominator, so what we have to do is to multiply with its conjugate. So what is the conjugate? If the denominator is 5 minus surd 3, the conjugate will be 5 plus surd 3. So expand everything. So what we have as a result is, for the top one, what we have is 10 surd 3 plus 2 surd 3 square will be, it will be 3 only. So 2 times 3 will be 6 for the top one. How about the bottom one? So for me, I don't have to care about the middle one. So what we have to do is just multiply 5 with 5. Okay. So what we can do is just multiply with A and B with B. But don't forget the negative sign here. So 5 multiplied by 5 is 25. Negative surd 3 multiplied with surd 3 will be negative of surd 3 square. So we will cancel out the square root and square. So what we have is negative 3 directly. So what is the answer? On the top one, it will be 10 surd 3 plus 6. And then the bottom is 25 minus 3, which is equal to 22. Okay, for example 3, I want you to try on your own for question. So I give you the answer for question A, which is equal to 11 minus 85 over 6. So please try on your own for question A. So let's move directly to question B. Okay, so for question B, so the question asks you to find and simplify 1 plus Z2 over 1 minus Z2 plus 1 minus Z2 over 1 plus Z2. So if you're thinking smartly, we don't have to multiply every of the fraction with its conjugate. So what we do is to find the common denominator first. So the common denominator for this part, how to find the common denominator? Yes, we just have to apply the cross multiply, and then we have the common denominator at the bottom. So for this side, 1 plus Z2 will multiply with 1 plus Z2. So the second part for the right fraction, 1 minus Z2, we multiply with 1 minus Z2. So the bottom one, we will multiply with each other, 1 minus Z2 multiply with 1 plus Z2. So we will have the common denominator here. And then what we do, we just simplify everything, expand everything. So 1 multiplied by 1 is 1. 1 set 2, 1 is set 2. 1 set 2 is set 2. So we have 2 set 2, and then set 2 multiplied by set 2 will be 2. And then for this part also, we will have 1 minus set 2 minus set 2. So this one will be minus 2 set 2, and then this one is plus set 2 square. So set 2 square will be cancel out. And then at the bottom one directly, 1 multiplied by 1 is 1. Negative set 2 multiplied with set 2 will be negative 2. So I will have the top one as 6. Why? 1 plus 2 plus 1 plus 2 is equal to 6. And then the middle one, 2 set 2, here is negative 2 set 2. So we'll cancel each other. So we left with 6, and then the bottom one is 1 minus 2. So it's negative 1. So the answer will be negative 6. I think that's all for this part. Please try other examples.